Hello, everyone. We will present you our own mini course, in the US mini course, which is more or less an exercise on how one can use analytical results from spatial analysis, and specifically from the build form. And this could be translated into a strategy for urbanism mobility planning. So this is the main idea of this course or mini course that we will present you. First, I will make a very brief presentation upon the concept of this work. Then Stefanos will present the principles and ideas of integrated mobility urbanism planning, and we'll take it from here. So the building blocks, let's say of this mini course, is to utilize composite urban form types in order to read and understand the urban space, the city, and translate them into actionable solutions or interventions. Just a clarification here, we're not proposing that only built form and urban form can be the sole input for a planning process. We're just demonstrating how this rich in information characteristics of the city can provide useful information to have a first idea, to have a first approach on a city level, and to have a first, let's say, run on how to plan a city by incorporating both land uses and stuff like that, but also mobility interventions. So we will use spatiofunctional urban form types, addressing both form and function, as a quantitative spatial language, decoding urban space, linking it to analytical findings, to plan solution, and using them for arguing, for supporting the interventions. Specifically, we'll use the three fundamental aspects of urban form, which is network centrality, built density, and functional mixture. So, as you probably can understand, urban form is an important aspect of the city, and urban types are a valuable tool for reading and planning it. We'll focus on exploring the typologies of these three elemental components of urban form, which have been used extensively in relevant research, and specifically build density, network centrality, and functional mixture, as already mentioned. But why we're going to use urban form types? Because they constitute the backbone of the city, and they refer to characteristics hardwired into the character and performance of the city, and actually characteristics that are difficult to change through time. They also function as proxies, as the descriptors of the urban system, crucial for the everyday urban life, and also important that there are open data sets available for the European urban space, providing an accessible and cost-effective plan support framework by using this type of analysis.
Hello, I'm Stefanos, and thank you, Yannis, for giving the floor. So we're going to discuss today the integrated planning strategy and what can we do to see urban space from a holistic perspective. Because to date, we had problems when we tried to design and understand cities, and each of themselves tried to understand city from different perspective. For example, an architect or an urban planner tried to understand urban space from the concepts that they know, but on the contrary, a transport planner couldn't get into that discussion and tried to formulate networks with a different perspective and a different approach. So we tried to combine these kind of different approaches, as Yannis said, and bring together, for example, planners, environmental scientists also, transport planners, sociologists, and a very broad variety of disciplines that address urban spaces issues and dynamics. So integrated planning for accessible cities, that is like the topic that we're going to focus. It's very important because we tried to link the urban aspect and transport dimensions. And thankfully, we have a hands-on practice later that is going to help us demonstrate to you and help us, all of us together, co-create measures on integrated urban and transport planning. So one very, very important concept is how we define accessibility planning. And we may find two different pillars, but these pillars could, let's say, be distinguished one from another, or they could cooperate. So we have one is the connectivity aspect of planning. So how we connect land uses and things with each other. This is the first one, and we can see here in the diagram a schematic visualization of how different kinds of connections bring different kind of impacts on the city. So we can see a hub and spoke approach that we have one center and we connect all the other neighborhoods to that center, or we can connect them all together, which is the point-to-point approach. On the other hand, we have the proximity planning, and it's very important that it's not a brand new concept, but it's got more popular, let's say, after COVID. So we have this rebranding of a 15-minute city, X-minute city, and stuff like that, and we're gonna use that approach in our hands-on practice as well. And what we mean about proximity planning, we mean to be, in other words, and in plain words, how we plan new land uses or distribute or redistribute the existing ones. So connectivity is about connecting, and proximity is about creating new points that will change the urban space, not only the activities themselves, but how we also move. So you can see here, we have this traditional segregated plan in the left case. Okay, you can see that here. We have this segregated, the job is segregated to the entertainment and the residents. But on the other hand, we have this proximity planning approach that we try to merge them and to bring them more closer, to bring them closer to one another. So from a polycentricity that is really, really confusing, we try to rethink of our cities as something more integrated. And also this visualization is very, very helpful for our purpose. So this is also the 15 minutes framework that I've mentioned. I think that many of us would have heard that, but if we don't, it's like a time-based planning approach that for some time thresholds we have to serve our needs, let's say, our basic needs. So the maximum threshold is 15 minutes. Okay, we can find 20 minutes in other research plans, but 15 minutes is the most popular, and it's something that started to be implemented in Paris during 2020. And this is the main, let's say, good practice example that we have. But also, there were many attempts in Latin America as well with this X-minute framework of planning, and we can see that the different time thresholds that also address different needs that we have. So another example of connectivity planning right now, not proximity, because 15 minutes framework is about proximity. Connectivity is about reclassifying the streets and also bringing the connections, thinking the connections and implementing them differently. So to date, or like 15 years ago, the classification of our streets was car-oriented, but now the paradigm is shifting towards a more sustainable street classification that we consider street space not only for cars, but also for pedestrians, for people with disabilities, for other valuable users, for cyclists, for e-scooters, and primarily for public transport. So street classification is a tool to connect different land uses, different activities, different places. And it's an example for connectivity. And let's see some measures right now that will help us for our hands-on practice later, because it's not only just showing you the measures, but to understand their concept and to understand us as the better that we can in these hours that we have available is to understand their impact. So first of all, we have many measures that you are gonna consider next, but we have distinguished them. We have divided them into three categories. The first one is the connectivity, to match the connectivity and proximity planning. The second one is the proximity, and the third one is like a common category that we like include measures both addressing connectivity and proximity. So in connectivity, we may find measures more connected to transport planning, like new bus lanes, tram station, metro station. So we have the fixed route transport, which is very important for our cities. We also have the thing of street classification and some more measures of restricting car use, parking, and to promote bikes or e-scooters. So you can see some pictures to understand the visualization, or how we imagine, or how are some examples in the planning approach. For example, here is the metro lines or a bus lane. You can see this picture, and this one is here. This is a multimodal corridor. It's like taking a corridor destined to cars and differentiating and giving different priorities for different users. So these are the connectivity measures that you are gonna employ later. Here we have the proximity, new public spaces, new land uses plan, support of local economy, which is very important when we deal about proximity, because proximity is about new land uses, and new land uses need somehow some incentives to emerge and also to prosper. So we have the new local centers. It's very, very connected to the land uses plan and street activities. These are all measures more of the urban aspect, more connected to the urban aspect, not to the transport, but they are very important as they have impacts on the way that we generally live and feel our city. Okay, this is our final category, the common measures. And here we have more or less the shared street approach. Is like sharing the pavement, sharing the pavement of the street. It's not the usual segregated approach like the pavement for pedestrians, the asphalt, for example, for the car, for cars or motorized movement, but on the contrary is merging them together and allowing their interactions. And one more that is really, really important is tactical urbanism, and all these pilot measures, again, something emerging during COVID times, and the green corridors that are some kinds of different connections, different connectors, but connectors of green spaces. So it's a common measure, because we have to think about the green spaces and also to connect them appropriately. That could be the measures, that could be the connectivity and proximity planning. And I think that you are gonna comprehend that later with the hands-on. This is just to the concept behind that, but the real practice will help you. And do you want to change? Do you want to continue to the scenario planning?
Okay.
Okay, perfect.
Sorry.
And a bonus before I giving the floor back to Yannis is about scenario planning. Okay, we want to demonstrate some concepts about that as well. Okay, you see that? So right now, each team will not formulate different scenarios, but all of them together, because all of us, we co-create measures. We're gonna incorporate that approach, the approach of scenarios. And what we mean by scenarios is like not a new, but a very essential step in planning. We have analysis, okay? And the traditional step was just to plan, okay? We analyze something and then to plan it. But what we miss is this link, the link of scenarios, the link of different perspectives, different pathways in the future. So a scenario or scenarios are tools that envision different pathways for the future and help us being more flexible and to understand complexity and uncertainty. So planning is like a complex process, but with scenarios, it gets more improved and more flexible. So with different scenarios, we can acquire different priorities and also being more ready for uncertain events in the future. So these are some steps to visualize the future. And I'm gonna show you the two more important approaches. The first one is the forecasting, which is like getting to the future, to prospective studies, what if, or how we see the future. This is the forecast, and it's mainly quantitative. But on the other hand, we have the backcasting approach, which give priority to the way of thought is how we imagine the future, which are the steps that we need to take to lead us in a future pathway. So they're totally different one another. Backcasting is more qualitative. And today, our practice would fall into the second category, into the category of being creative, not to take trends and prospect the future, but to create our actual trends, our actual new future condition. So one also important question and issue about scenarios, how many of them? We have 2, high vs low. We have 3 when we have the existing condition and 1 worst case and best case scenario, or something related to temporal variation like short, medium, and long term. And also 4, which is the cross, when we have 2 dimensions and they formulate 4 different kinds of future conditions. Here is one also example that is very helpful for our practice later. We're gonna implement strategic and conceptual scenarios, and it's closer to that look. It is very helpful. We're not gonna implement actual scenarios, and this example demonstrates actual this difference. The first one is the approach of connecting something or creating new land uses somewhere, but the right one is exactly the point that we're going to implement, for example, a new local center, or the actual street that we're going to use for a new bus line or for a new pedestrian corridor and stuff like that. But today we are going to practice on the left with conceptual scenarios. So these 2 pictures help us understand the difference between connecting conceptually and connecting or planning by proximity actually. So click here. This is our picture, and thank you so much.
So hello again. We'll continue with presenting a bit about the analytical tools, let's say, that we'll have for developing our scenarios, our plan proposals during the hands-on activity. Hopefully you can see my screen now. Great. So the main tool, let's say, the main framework that we will use for analyzing the study area and also proposing specific interventions would be the composite urban form types that I mentioned introduced at the beginning. So let's talk a bit about the different components of analytical components of the various the different aspects of urban form. Here we have the build density, which, as you may understand, can be defined as it is a multivariable phenomenon, and it's not just how many dwellings per hectare we have, but really how the different typologies of buildings and configurations can create different forms. So the two analytical components will be used is ground space index and floor space index. Ground space index reflects the coverage or compactness of the development, as you can see in the concept figure on the left, while floor space index gives an indication of the building density of in an area, refers to the whole building volume, as you can see on the right. And what is, to our point of view at least, interesting is that these different analytical components can provide different morphological definitions. For example, or specifically actually, ground space index, the coverage, the build coverage, provides the morphological definition of spacious, compact, and dense, while the floor space index provides the morphological definition of low-rise, mid-rise, and high-rise. While both of them, GSI and FSI, can provide a definition of minimal build density. What I mean by that is that here we can see how the statistical signature, let's say, of the components, or to say it more simply, the performance of the metrics can be create different types of building types, which is in some case we have very low GSI, but also very low FSI, or high GSI and high FSI, and how these components can be translated into specific morphological definitions. For example, the very low GSI can be translated as low rise, while the high FSI can translate into high rise, and how these morphological definitions that have been linked with specific performance metrics can result to composite build density types. Now we have spacious low rise, dense mid rise, dense high rise, which is a way of describing urban space, but which is symbolic and understandable for everyone, but also is linked to specific performance and quantification of metrics. Moving, and more importantly, actually, all this can be mapped for our study area and specifically for Athens, because as we mentioned at the beginning, all this data and all this information is generated by open data, so that they're available for the whole European urban space. So, for example, here we saw how the performance of metrics can be translated into specific types and spatial language for the build density, and how this can be mapped and highlight the patterns of build density of Athens. Moving to the functional mixture, which refers to land uses and human activities, and encompasses more information about the socioeconomic characteristics of a city. As our goal here is not just have the land uses of a city, but to describe the functional form of a city, which a usual land use map is not enough. To this end, we propose multiple analytical components that quantitatively describe the types of functional mixture. We have the residential function that be quantified by population density, while we have the everyday life amenities and facilities that can be quantified by the density of relevant points of interest, and to the same extent, in the same nature, we have the density of commercial facility and the density of tourist facilities. So this sleep, live, pay, visit concept can be used to understand the different components of urban functions. And more importantly, or also, this can be supplemented or should be supplemented by the presence of urban green and active leisure, which is an important aspect both for the configuration of space, of functional configuration of space, but also an important thing on how it is our cities. So these different components can be translated, can provide specific morphological definition, specific spatial language. Sleep can provide non-residential, sparse populated, residential, and dense residential characteristics. Pay can give the characterization of commercial, highly commercial. Live component can provide the words of limited presence of everyday life facilities and significant presence of everyday life facilities, while visit can characterize as tourist and highly tourist area. And finally, the urban green and active leisure can provide the plus, let's say, characteristic of substantial and extensive access to urban green and active leisure. So all these different aspects that I try to describe here can be understood, can be mapped, let's say, or put in table. So in the same nature, in the same idea that we discussed for the build density, the different performance and quantitative quantification of the metrics that we described before for sleep, pay, live, and visit can be translated into specific characterizations as sparse populated, residential, and so on for sleep, or commercial and highly commercial for pay, limited and significant presence of life facilities, and tourist and highly tourist for visit. Exactly linked to their quantification, more or less. And these components, this component of the language can be translated or transformed, let's say, into a composite type, which is actually a long description of an area. For example, we have dense residential commercial areas with significant presence of everyday life facilities, and all this idea, all this information can be symbolized, can be put as a label to find some ways to be more, let's say, symbolic on understanding the different patterns of functional mixture. For example, the dense residential and commercial areas with significant presence of everyday life facilities, which is a description that comes directly from the quantification of the performance of metrics, can be labeled by the researcher, by the planner, as a commercial neighborhood. But even if someone does not agree with this label, it's not according to their understanding, it can go back to the long description, let's say, that it's descriptive and directly linked to the performance of metrics. And in this example, it is a dense residential commercial areas with significant presence of everyday life facilities, which all these are supplemented and completed, let's say, by the description given by the urban green and active leisure. So in the example that we have a commercial neighborhood with substantial access to urban green and active leisure, with extensive access or with no access actually to urban green and active leisure. And all these kind of complex types and with different components can be mapped and help us characterize the different areas, the different type of areas of the city regarding their functional pattern. So, for example, I don't know how much of you know Athens. For example, the historic center of Athens has been identified as a central business district and tourist land without substantial access to urban and active leisure, while the areas of Gazi and Keramikos has been identified as commercial center and tourist land, again without substantial access to urban green, while the Plaka area is with substantial access to urban green. So we can see how these different types of functions can create a spatial representation of the city, but which is also linked with a spatial language that can be used for arguing about our desires and our interventions for the city. Moving to network centrality, which is a kind of a more complex issue, but maybe some of you are familiarized with space index and these kind of approaches. Network centrality is defined by space index and traces the inherent property of space to shape human activity and human movement in space. And but also in our approach, apart from the space index, we wanted to include the infrastructural characteristics of network that can produce centrality. So, moving to analytical components again, for network centrality, we have angular betweenness that reflect an angular closeness. Closeness, which also is known as integration, reflects two movement potential, meaning the potential of space or place to attract movement as a destination, as can be seen also by the figure here. So this aspect of the network can provide morphological characterization, as seen before, as integration, core, segregated fringe, and baseline. And this, as seen before, can be also mapped for Athens, for any city. Actually, this is the example of Athens. In the same idea, we can have the analytical components of network centrality, specifically now focusing on betweenness, which reflects the through movement potential, meaning the potential of a place to attract movement as a route, as a pass through space. And this also provides characterizations based on the radius that we have significant betweenness potential. So we have areas with local centrality that that are central in low radius, areas with network centrality that are substantial presence of neighborhood routes, meaning routes that are high on medium scale, let's say, and also areas with city centrality that are substantial presence of city routes, meaning routes that are high in radius like 3 kilometers, 4 kilometers, 5 kilometers that are relating to high distance movement. But also have areas with diverse movement that have multi-scale neighborhood centrality, meaning we have routes both of local and neighborhood nature, and areas with multi-scale city centrality that for sure has city centrality routes that are important in high radius, but also radius that are important in smaller radius. Routes that are important in smaller radius. So this is how the different betweenness types at street level can be mapped, and how this is translated into areas, and how we have betweenness types at different areas based on the presence of different type of routes. So here we can see how the integration types, the closeness types, meaning the potential of a place to be used as a destination, and the betweenness types, meaning the through movement potential, can be combined. And finally, we have, as mentioned in the beginning, we have integrated also the infrastructural defined centrality or the rich centrality, and specifically the active mobility conductors and access to high-speed public transport. What we mean by that is that we identified areas with metro in walkable distance, meaning areas with access to high-speed public transport supporting long-distance STEM mobility, and also areas with active mobility connectors supporting human-scale movement, meaning that we have significant presence of hard infrastructure for active mobility. I understand that all these different aspects that are presented here, and especially for network centrality, can be a bit confusing. However, at the end of the day, at the end of this analysis, we have this map that we hope that it's kind of intuitively can be understood intuitively, meaning that with the color we have the scale of its neighborhood, the scale of its area, meaning the scale in which the routes can attract movement as pass-through routes, as pass-through areas. And we have areas with local centrality, with network centrality, but also areas with diverse mobility movement as neighborhood, multi-scale neighborhood, multi-scale city centrality. And also we have, on top of that, whether are integrated or segregated. So, for example, to go to the example of Syntagma, of the area of the historic center, we have an area that is it's an area with multi-scale neighborhood centrality, which is also has with active mobility conductors and with access to metro station, while the area of Exarchia, it's an area with local centrality, integrated local centrality, with active mobility conductors without access to public transport. So, closing this presentation, with these different approaches, we can at the end of the day can produce different representations of the built environment that are crucial to understand and plan the city, especially because there can be proxies for aspects of the city that the data are not easily available. So we have the patterns of build density on the left, which is a proxy for the sociocultural patterns and the process for the production of space. While on the right, we have the patterns of functional mix, which are proxies for urban activity and human practice in urban space, while the patterns of network centrality can be a proxy of urban mobility that aims to predict human scale movement. So yes, this was all by us regarding the presentation. Before going to the hands-on activity, would like to ask you if you have any question, something that you want to ask. Okay, I don't see any hand or something, or even in the chat, I don't see something. So okay, I think we can move on to the hands-on activity. Let me first share with all of you a Google Drive link. Give me one moment.
Yanis, I think we had a comment on the chat.
Sorry. Yes, the presentations will be all the presentations will be made available in the Open Learning Platform of InPlaLabs, which will be in the Helios platform of NTUA. Maybe next week or something we will have everything uploaded, and we will send you the link for anyone to access them. Any other comment or question, something? Okay, so hopefully all of you will remain active now in the hands-on activity. That will for sure will require some interaction with all of us. I will send you now the link to the Google Drive. Let me. Okay. And before dividing everyone in breakout rooms, I will go through a bit through the hands-on activity to be able for all of us to follow through, and yeah, let me just find. So, one moment. Okay, can you see my screen again? Great. So, in the link that I just shared with you, we have this document that is just for helping us going through this hands-on activity. One important thing is the mirror that we have here. I will open it in a bit, but that's giving you the idea for the whole hands-on activity. In this activity, we try to imitate a planning process, more or less, that one may find themselves in place to have to prepare a strategy or something like that.
You can see this. It's your middle.
Okay. Yeah. I'm sharing my whole screen to be able to see it. Is it okay now? Okay, great. So in this world, we have the different stages that we will that one may find themselves when in a planning process, in a planning procedure. So at the first stage, we will have to specify our vision regarding this planning strategy, and specifically rank our planning priorities. Then we will have to do the analysis of the study area by focusing both on the whole city and inside your designated study area and making some remarks. All of this will be done in the Miro. Maybe I will go here now just to see it yourselves. So here is the Miro that So we will move one step at a time. At the first step, you will have to rank your plan priorities. Then to analyze a bit the study area by using also a web map that we have created that has all these things that I presented, all these different types. So you would have to go through your study area and comment, make some remarks both for the whole city and inside the study area. Then you would develop your scenario, let's say, of your 15-minute strategy by studying the cost interventions that we have here in the link. So each team would have to select a measure from the list. For example, if I choose this one, then one minute, because it just stopped working. Let's use this one. Okay, this works. So yeah, you will select the different interventions, and you can see you have a budget to abide by, which is 20 coins, let's say, and you have to not exceed it. When you select it, then automatically finds what is the category of the measure and its cost. Then, after you have selected the measure, you have to specialize it and put it in the corresponding area on the map here. And then you would have to make some arguments about your identified proposals and stuff like that. So I'm proposing to have just a 5-minute break just to be able to divide you in teams. We will do it in breakout rooms. We will assign you ourselves, and in 5 minutes we can start working on the hands-on activity.